they're very similar to volume. There's this concept of density. And a lot of people kind of intuitively kind of have this idea of density as being about how like heavy something is. Doesn't have anything to do with how heavy it is, really. But density is actually like, if you had two items that were the exact same size, the one that's heavier would be denser if they're the exact same size. So when I go shopping for watermelon and cantaloupe, I actually apply the idea of density when I'm buying a watermelon or cantaloupe. Pick up a couple different watermelons or cantaloupes, whatever it is I'm looking for, and the one that feels more dense is the one that I get, because water is more dense than the actual flesh of a melon. So the more dense it is, the heavier it is if it's the same size. The more dense it is means the more water, the juicier, the better the melon's going to be. So that's the idea of density. If it's the exact same volume, the one that's heavier has a higher density. So you can calculate density by doing mass divided by volume. Mass is the actual mass of it. Like, that's more like the weight. So here's two different types of wood. Wood has different densities. Metals have different densities. Fat has a different density than muscle. So here's Douglas fir and American redwood. We've got the diameter, we've got the height. They're cylinders because that's what logs usually are, is a cylinder shape. And we know the mass. So we're going to determine the density of each log. So for each of them, density is mass divided by volume. We know the mass, we need to find the volume so we can divide it. So for the Douglas fir, we need the volume. Diameter is 6, the height is 17. It's a cylinder, so the volume is pi r squared times h. Diameter is 6, so the radius is 3. So 9 times 17 times 3.14, 480.42. That's the volume. Density is mass divided by volume. So mass divided by volume, 254 divided by 480.42. The density of the Douglas fir is 0.5287. We'll say 0.53. And for the American redwood, we need the volume of that. It's a cylinder, so same formula. The radius is 4. Height 12. So the volume is 602.88. Density is mass divided by volume. So 271 divided by the 602.88, we get 0.45. So determine which wood is denser, more dense, bigger value. 0.53 is more dense than 0.41. Douglas fir is more dense. There's also a concept of population density, which is just how tightly people are kind of packed into a city or a country or whatever, which is population divided by area. So however many people there are divided by however large the place is, that determines the population density. So here's this Burlington, Vermont. Has an area of about 160 kilometers squared, so 160 is the area, and a population of 109,000 people. What is the population density? So you just 109,000 divided by 160 kilometers squared. That's 681.25. That was people. And then our denominator was kilometers squared, so it's people per square kilometer. Now for the entire state of Vermont, says it can be modeled with a trapezoid. So they're not giving us the area, we have to actually calculate the area. To approximate the population density of Vermont. So it says each unit is 1 mile. So if you're going to find the area of this, there's one way you can do trapezoid is to split it into a rectangle and a triangle and find the area of each, add them together. Or it's 1/2 base 1 plus base 2 times the height. Or you find the rectangle and the triangle separate and add them together. It doesn't matter. So first base, one of the bases here is, what are they counting by? 20s. So this is 80. So this base has a length of 80. This is miles. This base has a length of 40. 80 plus 40. And then the height is 120, 40, 60. So it has an area of 9,600 square miles. Population density is population divided by area. So we're going to take the population, 626,000, divided by the area, so that's about 65.2 people per square mile. Find the population density of Chicago, which is approximately a parallelogram. Each unit represents 1 mile. So this is counting by fives. So that has a base of 10. This is a base of 10. The height is 20. So parallelogram is base times height. So that area is 10 times 20. 200 square miles. and it has a population of 2,715,000. So the population density is people over area. $13,575 people per square mile.